So hello guys, I hope you have seen already the previous video. Now we are going to second part of previous year question of JEE means 2024 of organic chemistry. So the today's first question is the order of relative stability of the contributing structure. Means they give us a three structure of the same compound. We have to tell that out of these three structure which one is the more stable. So these three structure are, so these are the three structure which are given in the question. In the first structure, the this in the first structure the given compound is a neutral. In the second and third are charged. So I hope you have studied about the stability of the compound. The compound which is neutral, this is the more stable. So among these three, first one is more stable. Now what about second and three? So in the second structure, the negative charge in oxygen atom and positive charge in carbon. Here the negative charge on carbon and the positive charge on oxygen. So oxygen is a more electronegative than the carbon. So negative charge will be well stabilized by the oxygen than the carbon. So here in third structure, negative charge is on carbon and positive charge is on oxygen. So as the negative charge is more stabilized by the oxygen, therefore this negative charge is stabilized by oxygen, therefore the second compound is more stable than third. So here four options were given. Among these, the first option is this. Which one is correct? Now the next question. So the today's second question is, when among the following halides will not show SN1 reaction. Means they give us four structure. We have to find out which one will not give SN1 reaction and which one will give SN1 reaction, which will not give SN1. So what is SN1 reaction? SN1 reaction means unimolecular nucleophilic substitution reaction in which carbocation is formed and that carbocation is well stabilized. Means it may be allylic carbocation or 3-degree carbocation are more stable. So if these two carbocation are formed, then this compound will give SN1 reaction. So here four structure are. The first structure is this. In this structure, in this compound, if this in SN1 first leaving group is knockout and carbocation is formed, and this carbocation is well stabilized by this pi bond. Means this is the allylic carbocation, so this is stable, so this will give SN1 reaction. In that structure, if leaving group is knockout, the carbocation is formed and that sp2 hybridized carbon atom. So sp2 hybridized carbocation is more electronegative than sp3. So how we can say that more electronegative? sp2 and sp3. More is the S character, then more is the electronegative. So on more electronegative atom, the positive charge is not stable, so this will not give SN1 reaction. Now the option C. Here, if chlorine leaves out, carbocation is formed and that benzyl carbon, and this carbocation will be well stabilized by the double bonds in the benzene ring by resonance. So therefore it will also give the SN1 reaction. Now what about D? Here also, if chlorine group leaves out, carbocation is formed on secondary carbocation. This will also stabilize, we can say stabilize. So this will give also SN1 reaction. So what is the option? B. B is the correct option. The question is which one will not give SN1 reaction. So what is the option? B is correct. So now the next question is, third question is, phenolic group can be identified by the positive test. Which one is the test to identify the phenolic group? The first you should have to know about the phenolic group. Phenolic group has a structure, this one. So which test is used to identify that phenolic group? Here the four options we are given. A is the Thalin state, Thalin test. B is Lucas test. C is Tollens test. D is Carbamide test. So if you studied already about this test, I hope you know the B Lucas test is used for the differentiating primary, secondary and tertiary alcoholic group. What is Lucas test? Lucas test is here HCl and anhydrous ZnCl2. These are used to differentiate primary, secondary and tertiary alcoholic group. How you can differentiate these three group? These three alcohols. Tertiary alcohol use immediate turbidity, secondary alcohol use turbidity after 5 minutes, and primary alcohol group not give turbidity, but it will give after heating. So here option B option is not correct for phenolic group. Now what about tolerance test? The tolerance test is used for the identification of carbonyl group. Which are the carbonyl group? Aldehyde and ketone. So here tolerance test is used to identify the aldehyde and ketone, and D is used to identify the primary amine. So what option is remain? Thalin test. So thalin test is used to identify the phenolic group. So here the correct option is A. So now the next question is. So now the fourth question is the molecular formula of the second homologue in the homologous series of monocarboxylic acid. Here we have to find out the second homologues in the homologous series of carboxylic acid. What is the general formula of carboxylic acid? CnH2nO2. They asked us the second homologue means N is equal to 1. Then what will formula become? N is equal to 2. C2H4O2. So if you can't remember this formula, then the first homologue of the carboxylic series is formic acid. Means here the one carbon is there. Now the second will be, what will be second? Two carbon means acetic acid. This is the second homologue of homologous series of monocarboxylic acid. So here the four option we are given. Among these, the second option is C2H4O2. So therefore second option is correct. Now the next question. In the next question, the question is the final product A formed in the following reaction. Means we have to find out the final product. The reaction given is here this compound called as styrene. So here first reagent given is BH3, second one is H2O2 OH minus, then third one is HBr, fourth reagent is magnesium in ether, then formaldehyde in hydrolysis. So we want to find that A product. What will be the A product? First, this is the BH3. This gives the syn addition to the double bond, and this do combine two reagent. We call it a hydroboration oxidation. So first, if we added to styrene BH3, it will give homo syn addition. Then what will happen? Here is the BH2 and H minus. This attached at double bond. So what will fall? So what will fall? Here H will become and here BH2. Now the by oxidation, what will happen? PH CH2 CH2 OH. This is the total reaction called a hydroboration oxidation. I hope you have already studied. If you have not studied, then I will teach the hydroboration oxidation specially in one of the video. Now the third reagent is HBr. So this is the acid H. So it will give H plus, and the lone pair of oxygen will accept the H plus and will form hydronium ion CH2 CH2. So H plus will become one oxygen. So simultaneously this Br minus will attack and this water will be knocked out. This water will be leaved. So now what will be the product? pH CH2 CH2 Br. Now the what is the next reagent? Magnesium in ether, or we can say dry ether. What will happen? Insertion of magnesium in alkyl halide group means insertion in that carbon and bromine group. So what will the product? CH2 C2 magnesium bromine. So after that, what is the last reagent? After magnesium they added formaldehyde. So what will happen? This is partially negative charge, partially positive charge, partially negative charge. So this is the nucleophilic addition reaction on that carbonyl carbon. So what will happen? pH CH2 CH2 C, and this will go to oxygen O minus here plus 2. And after hydrolysis, what will happen? pH CH2 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 OH. This is the final product of our reaction. So here the correct option is 4. The D option is correct. So now the next question. So the next question is the major product formed in the following reaction mixture. We want to find the final product in that reaction. So what will happen? This oxygen has lone pair. This is the acidic proton. This will accept this H plus. What will come? Positive charge will become oxygen. So now, which bond will be break? This or this? If this bond is broken, means this bond pair is accepted by that oxygen. So the carbocation formula is secondary. And if this bond is broken, then which carbocation will form? Plus tertiary carbocation is formed. Here secondary carbocation is formed. Here tertiary carbocation is formed. So which one is more stable? The tertiary carbocation is more stable. Therefore, this will be the major product. Finally, I minus will take on that carbocation, and the final product is plus I. So here the option given is last option. D option is this. So here last option is correct of that question. So now the next question is. So in the next question, the question is the bond line formula of that given molecular structure formula. The bond line formula. So what is bond line formula? If suppose CH ethane is there, what is the bond line formula of that? Simple, one line is here CH3 CH3. Now if CH3 CH2 CH2 OH, the bond line formula of that is CH3 CH2 CH2 each benzene OH. This is the bond line formula of methane propanol. So now what will be the bond line formula of this? So here the central carbon is, let's suppose there is central carbon. Here two CN group are. And here one OH group is there. Or other Another way we can draw the one line formula by here, then here, then here. These both are correct, but in the option this one is given. So here the option is this. So therefore this is the correct option. This is also correct, but this is not given in the option. Therefore this is correct. Now the next question. So thank you guys. Remaining part we will discuss in the next video. I hope you are understanding well my teaching. And thank you.